Hey y'all, Data Guy here. And today I have a video for you where I'm going to go through around the top 10 roughly biggest terms that I see thrown around in the data engineering space. So this video is really just meant to be a guide to, hey, I'm trying to break into data engineering. I need to understand all these different tools, what they mean, what's the common terminology that data engineers are using, so that I don't have to ask the silly questions to someone and they think I'm dumb. Obviously, there's no such thing as dumb questions, and that's why I'm going to answer some of them for you today. And so the first term I want to break down is big data. And so big data refers to extremely large data sets that are beyond the capability of traditional data sets to capture, to store, to manage, to analyze, to really do anything with because they're just so large and that running a query on them would just take an extreme amount of time. But what's good to note here is that the term is not only around the size of the data, but also the variety. Big data refers to a lot of times situations where maybe the size isn't, terabytes and terabytes, but it includes new types of data like video, like images, like tweets, right? And especially in the age of AI and ML, this type of data is crucial for actually, building these ML models. You need to have that raw kind of user level data. Um, and so big data is super important. And you see kind of there are a lot of people call like different V's around big data, the volume, variety, velocity, but I'm not going to get too deep into that. Just know big data is referring to really large and complex and varied data sets. And some common tools that you'll use to interact with big data are things like Hadoop, Spark, and NoSQL databases to actually manage kind of that sprawl there. Now, the second term I want to break down is data warehousing. And so what distinguishes, data warehousing from a database is that a data warehouse is many times kind of a collection of many different databases. It is really designed as a centralized, repository that will store data from many different sources in a consistent format to allow you to support analytical and reporting capabilities downstream by having all that data in the same format, even though it's coming from many different sources. And this differences it from operational databases, which are used for things like transactional processes and just storing the raw ingestion of that data. Data warehouses are really designed for storing that raw data after it's been cleaned, after it's been put in a structured way, and optimizing it for querying and analytics by end users. Giving you a comprehensive view of all the different data sources in your operations. In this case, staging, reporting, metadata, all in one single location, so you can kind of make those inferences between those different sets of data to understand, high-level interactions within the data. And so some technologies that you'll be using to interact with this would be Amazon Redshift, Google BigQuery, Snowflake, all big popular data warehousing tools that offer great scalability, performance, and the ability to handle those really complex queries over the large amounts of data. The next term I want to get into is an ETL process. And ETL stands for extract, transform, and load. And it's a really critical process in data engineering that involves extracting data from various different sources, transforming it into a structured and usable format, and then loading it into a target database, data warehouse. And this transformation step typically includes things like cleaning, aggregating, restructuring the data to a common format. Typically you'll be doing an ETL process on raw data from those operational databases before you store your data in your centralized data warehouse. And so your transformation step is going to be cleaning that data so it fits your standards. And some common ETL tools, there's a whole wealth. Apache Airflow is a great tool. Talent, Informatica, the list goes on and on. There's a ton of different software out there to help you kind of automate these tasks and make sure it has a lot of things like data quality built in, higher level visibility into what's actually happening within these ETL processes. But key thing is just understanding what an ETL process kind of contains. It's three primary components: are an extraction from a source, transformation of that data, and then loading that data into a data warehouse. And then also it's becoming more popular with more efficient data warehousing tools is an ELT, where you extract the data, store it, the raw data in a data warehouse, and then transform it there because the cost of transforming it there is cheaper than it would be in an actual ETL tool. So something to note there when you see ELT versus ETL. Now, the next term I want to talk about is a data lake. And a data lake is a storage architecture that is really designed just to hold massive amounts of raw data in its raw native form. And so unlike a data warehouse where you're going to be transforming that data, you're going to be processing it before storing it in a kind of standardized format for all of your different data sources, a data lake just stores data as it is. There's no transforming on ingestion. Where the transformations happen is when it's actually needed. So unlike a data warehouse, you're going to have your data stored in an unstructured way, and then you're going to pull that data as needed to run big data, real-time analytics, and actually query and understand the data. So it relies on you actually taking that raw data and then, working with it after it's been stored in the data lake, rather than doing the heavy lifting of, cleaning it up, making it pretty for analytics before going into the data lake. And so in these, you're actually not going to use data warehouses. You'll typically use just cloud storage solutions like Amazon S3, Azure Data Lake Storage, and Google Cloud Storage, where it's a bunch of just kind of raw compute buckets. You dump your data in there, and then as it's needed, you can pull that data out, query it, and build kind of pipelines that actually query and interact with that raw data. Now, the next term I have is kind of a more generic term for an ETL, which is a data pipeline. And a data pipeline, what differences it from a ETL, is it's not confined to just being an ETL motion. Data pipelines are at their base level are a set of automated processes that you've written in code for moving and transforming data as it goes from one place to another. Obviously, very crucial component in the data engineering ecosystem, and this can range from everything from real-time streaming, where every time a new data point is created, it then gets processed and transformed, down to batch, where it's every time we get 100 data points, then we transform them all at once, or something like migration, where we're just doing one big pipeline that's only running to incrementally migrate data from one database to another. Tons of different use cases for data pipelines, and they're really core to data engineering, and they can involve many different stages, common tools. Again, Apache Kafka for streaming, Apache Airflow for traditional data pipelines, and those are, there's a wealth of other tools out there to help you build and manage data pipelines, depending on kind of what your use case is. But in general, data pipelines will typically consist of some kind of source, some kind of intermediary step where that data is transformed, and then finally an end result where that data is either published or stored in a what's referred to as a sink source. Now, next to the docket, we have NoSQL databases. So NoSQL databases are really defined by storing data in formats other than a traditional kind of table-based relational database. They're really useful for handling large volumes of unstructured data, giving you kind of the scalability, flexibility, and high performance you need, and the ability to scale your compute to match your data, so that you can transform this massive amount of unstructured data at scale. And so some common tools to interact with this are things like document databases like MongoDB or Couchbase. You have key value, which is a Redis or DynamoDB, wide column, Cassandra and HBase, and then also graph databases, which are Neo4j and Amazon Neptune. Worth a whole other video getting into kind of the different types of NoSQL databases, but each of these can be, they're optimized for different types of non-standard data and different kind of patterns of access. But the key thing to take away is a NoSQL database just refers to something where it's not like the traditional table that you're used to seeing. It's actually other formats where it's, might be, hey, these are your support ticket messages that we're storing in the backend of a Mongo database, where it's an inconsistent set of columns and rows and attributes to each data point within your data set. Now, the next term we have up is data governance. And the term data governance really refers to the practices, processes, frameworks that you as an organization put in place to ensure your data quality, your data privacy, security, compliance throughout a data lifecycle. And so what this typically involves is setting policies and standards for data management, and then also monitoring adherence to those policies to make sure people are actually following them, and also managing data access and usage. And this is really becoming more important as we get really large sets of data and also personal data that's being used for ML and AI models, where effective data governance is crucial to make sure that you're actually using that data legally, but also having accurate and available data. So not only meeting regulatory requirements, but making sure that, hey, data governance can make sure that these data sets that we're feeding into our model are adhering to certain standards of data. We know that they're in a certain format. We know that they're of a certain quality. Making sure, and all the downstream systems that are using that data, you can feel comfortable knowing that, hey, this is the most accurate data, and I'm not running bad processes just because I'm running bad data. And the next term I got to you is ML operations. So this refers to obviously machine learning operations, which are essential for the modern data engineer. If you're a data engineer these days, You're definitely going to be working on some ML or AI related work. If not today, then sometime in the next year. And ML Ops is a set of practices that aims to deploy and maintain machine learning models in production reliably and efficiently. So it combines machine learning, data engineering, DevOps to streamline the end-to-end machine learning lifecycle. So from things like data preparation to model training to deployment to monitoring to updating those models, MLOps tools are designed to kind of manage that entire process and give you visibility in every step of that process. Tools and frameworks include, things like MLflow, Kubeflow, TensorFlow, CV Vision, Llama. There's a ton of different tools. Airflow, even. Airflow has actually become a really big tool in MLOps because it's Python native. It's able to connect to all the different ML tools that you have within your MLOps stack. And so all these frameworks really help data engineers automate these processes, improve and track model performance and just ensure model accuracy over time. Now, the next term I have is kind of a two-parter in that I'm going to talk about batch and stream processing. So stream processing is a technology that's used to process and analyze data in real time as it is created. So in a stream process, a new data point is created. The data streaming tool, let's say Kafka, takes that data point, runs some processes to change it. Let's say, it's just my name, George Yates. It's going to cut out the last name and just store George. And that would be a data stream process. Now, batch, that is in kind of comparison to batch processing, where batch processing will wait for, let's say, 10 names to come in, and then it will run that same transformation on those 10 names at once. And so both of these have their place. It really depends on like, hey, do I need to have immediate insights and actions? That's where stream processing is going to come in handy. For things like fraud detection, social media analytics, monitoring systems. That's where you're really going to want to use stream processing versus, most data pipelines are going to be using batch processing. But some stream processing frameworks include, Kafka, Apache Flink, Amazon Kinesis, all enabling that continuous data processing, allowing, you to just react hyper quickly to any new information, any new trends, because you have that data available the second it is created, or at least a couple seconds after, because we got to wait for it to actually process. So those are those tools kind of compared and broken down. Now, the final term I have for you is a bit of an opaque one, and that is data fabric. Data fabric refers to an architecture and a set of data services that provide consistent capabilities across a choice of different inputs, spanning hybrid and multi-cloud environments. And what that, all that kind of word vomit is to say is it is really a centralized architecture that allows many different teams to interact with data on their own terms. And it's meant to really abstract away kind of the underlying processes that's generating that data to just enable really easy access and sharing of data across your entire network within the company. So, your finance is able to access the data they need, service is able to access the data they need, and they're also able to interact with each other and port data to each other. So maybe sales and marketing, they want to combine different data sets to find, some kind of correlation between marketing's activities and sales. A data fabric enables that by letting all the teams kind of talk the same common language and all interact with each other through a universal framework for how data is stored and transferred throughout the organization. So this is really critical at larger companies where you need to set a standard for how data is used and interacted with for a variety of different teams and an ever-changing different array of use cases. And that is kind of my top 10 data terms explained. If I left something off here that you were really hoping to see, let me know in the comments below and I will add it to a future video. But above all else, have a great rest of your day. Data Guy out.